It requires many billions of years to create a galaxy like the Milky Way system. Our insight into the universe grows a great deal consistently as researchers all around the world make astonishing revelations that change what we know today. We will discuss probably the freshest and less notable revelations that even the most experienced specialists can't sort out. Go along with us as we investigate the profundities of room and find mysteries that assist us with drawing nearer to settling the absolute most significant inquiries known to man. We'll take a gander at bizarre exoplanets that could disrupt the guidelines of physical science and unusual inestimable occasions that nobody has had the option to make sense of. Envision that a planet was found in the external pieces of our nearby planet group that follows its star in reverse contrasted with different planets. In addition to the fact that such a find be fascinating it would likewise raise doubt about current thoughts regarding how planetary frameworks structure. Analysts have as of late discovered a portion of these peculiar exoplanets. For instance, some circle their stars in exceptionally close circles, which makes the surface extremely hot and ready to soften metals. Others are maverick planets that meander through the world without a star. This makes individuals wonder where they came from and how they stay alive in the brutal climate of room. Understanding the intricacies of these strange grand bodies significantly grows the area of science. This significantly affects both scholarly interest and useful issues, for example, how we could live on different universes later on. Each new finding is a critical piece in putting the large riddle of the universe together. Ponder what it would intend to track down water fume on a distant world or to find a planet with an environment like Earth's. These outcomes could show where conditions are ideal for life to begin, which could assist with arranging future excursions to these distant spots. Understanding the exceptional shapes and ways of behaving of these planets likewise assists researchers with working on their models of the design and improvement of the universe. This gives us hints about the past and eventual fate of Earth. Envision that we find an exoplanet whose way isn't smooth, which conflicts with current speculations of gravity and makes us question what we assume we are familiar material science and how things move in space. In addition to the fact that this is somewhat data valuable for school, yet it will likewise affect innovation and space research. The finding of 2007 or 10, the biggest world in our nearby planet group that hasn't been named at this point, is a fascinating contextual investigation with regards to how to find and concentrate on heavenly bodies. This distant item, which is in the dispersed plate locale past Neptune, allows stargazers both new assignments and opportunities. Cosmologists found 2007 or 10 interestingly, while utilizing the Samuel Oskin telescope at Palomar Observatory for an ordinary check. It was affirmed to have been found by taking a gander at prediscovery pictures made by the Spacewatch project. This shows how space science is much of the time cooperative and like an investigator story. 2007 or 10 is the third biggest known Bantam planet in our nearby planet group. Its measurement is around 1,535 kilometers, which makes it an extremely enormous planet. Despite the fact that it is exceptionally large, it doesn't have a name yet on the grounds that we don't completely grasp its circle and haven't had the option to sort it out to the point of meeting the Worldwide Galactic Association norms for naming articles. Its surface is strangely dull and red, which recommends that it contains complex natural mixtures called tholins. These are made when daylight hits straightforward natural mixtures like methane and alkali. Did you had at least some idea that regardless of its immense size, 2007 or 10 stays anonymous in light of the fact that its circle has not entirely set in stone with sufficient exactness to give it a proper name. Its dull surface and slow pivot make it one of the nearby planet group's most subtle articles. The investigation of 2007 or 10 incorporates both direct perceptions and PC models that attempt to figure its way and sort out what its actual properties are. To accumulate data, cosmologists utilize the two telescopes on the ground and stages in space, for example, the Hubble Space Telescope. The light bends from these perceptions assist us with sorting out its surprisingly sluggish turn period. It requires around 45 hours to complete a turn, making it one of the Kuiper belt protests that pivots the slowest. At the point when you thought we had a universal knowledge of our planetary group, revelations like 2007 or 10 go along to challenge our viewpoints. In any case, hang tight. What we find next about another far-off divine body may very well rethink the unthinkable. This prologue to 2007 or 10 not just makes way for a more profound investigate odd divine bodies, Yet it likewise shows how we are as yet tracking down new things in the external nearby planet group. Each snippet of data we get assists us with diving more deeply into these distant universes and the universe all in all. Super-hot Neptunes are an intriguing gathering of extrasolar planets that don't act like typical planets. These items in space circle exceptionally near their stars, a lot nearer than Mercury does to our Sun. This implies that the surfaces of these articles can get exceptionally hot, over 1,700 degrees Celsius, 392 degree F. Being so near their host stars difficulties what we assume we are familiar the way that planets structure and how they stay alive in light of the fact that it can prompt environmental blow-off, which is the point at which the climate is really torn away by the radiation and winds of the star. To give you a model, contemplate KLT9b, an exceptionally hot Neptune that is hot to the point that particles like water can't shape and on second thought separate into nuclear hydrogen. Noticing these planets not just tests what we assume we are familiar environments yet additionally how well our current models of investing planets into bunches effort. Outrageous circumstances raise significant inquiries concerning the assortment and strength of planetary frameworks everywhere. On the off chance that you contrast super-hot Neptunes with different sorts of planets, what do you suppose the reasons are? Their shortage could have something to do with how they framed and the circumstances that must be met to make such cruel settings. Let us know your thought process in the remarks. Is it safe to say that you are keen on the insider facts of 2007 or 10? Simply hold on until you find out about AYSE 1348-34. What researchers found around this exceptionally huge star could be the way to sorting out how heavenly Goliath structure. This change from discussing exceptionally hot Neptunes to discussing AYSE 1348-34 proposes that we will keep on investigating the most interesting and most outrageous things known to mankind. Every point expands on the past one, zeroing in on the new revelations and amazements that continue to occur in science and make us question what we assume we know. AYSE 1348-34 is an exceptionally enormous star in the extremely profound pieces of the heavenly body Centaurus. Another investigation of this star has revealed new insight into how confounded star arrangement is. This immense, inestimable body, which is multiple times the mass of our Sun, has raised doubt about the possibility that enormous stars are generally made when more modest stars collide with and converge with one another. All things considered, the finding of a huge circle of gas and residue circling AYSE 1348-34 proposes that even the greatest stars could frame similarly that more modest stars do, by leisurely assembling matter from a protoplanetary plate. Such an outcome makes vital impacts. It's not only a level element. The plate around AYSE 1348-34 is moving and loaded with complex natural atoms and residue particles that connect with one another as the star's gravity arranges them. Indeed, even in these brutal circumstances, this cooperation could make planets structure, which could imply that researchers can thoroughly search in additional spots for new universes and perhaps life. Stargazers can work on their models of how stars develop and change over the long haul by diving more deeply into the circle's properties together. AYSE 1348-34's solid splendor and the gravitational draw of its mass make it a one-of-a-kind spot to concentrate on how matter demonstrations in a portion of the universe's most enthusiastic regions. This study is vital for both delineating the existence pattern of stars and investigating the chance of planets framing in places that were believed to be excessively antagonistic previously. Our next subject is maverick planets, which incorporates both the thrilling conditions of huge stars like AYSE 1348-34 and the secret planets that meander the universe. These puzzling bodies, which float in space without a star to circle around, make us ponder what a planet is and where they can reside. Maverick planets are both strange and educational. They are another boondocks as we continued looking for information about the world. Speedy inquiry. What might happen to a planet that isn't held set up by the gravity of a star? We'll find out with our next subject, which is maverick universes. We move from discussing colossal star frameworks like AYSE 1348-34 to discussing perilous planets. This is quite possibly of the most intriguing point with regards to space science. These are divine things that float through space without being pulled by any star. They are additionally called maverick planets or free-drifting planets. This is totally different from the typical thought of planets as things that circle stars in a reasonable planetary group. These unusual space voyagers aren't kept down by the gravity of any star, so they travel through the sky without help from anyone else. They're finding conflicts with the standard thoughts regarding how planets structure, which say that the gravitational draw of a star is expected to accumulate and shape planetary bodies. Rebel planets are remembered to frame in one of two ways. Possibly they are tossed out of their home planetary groups by gravitational pulls, or they structure on their own in a haze of stars that are as yet developing yet never get together with a star. Maverick planets are particularly elusive, and implies like microlensing are much of the time used to track down them from Earth. This happens when the maverick planet momentarily sparkles more splendid than a distant star as it passes before it. These occasions are intriguing, however valuable opportunities to become familiar with the elements of these meandering planets. Planets that go off base enormously affect how we might interpret the world. They show that planetary frameworks might be surprisingly mind-boggling and changing, and that the right circumstances for planet arrangement can occur in additional circumstances than simply those where planets circle stars. Likewise, the sheer number of these planets, potentially more than the stars in our own cosmic system, focuses to a gigantic secret populace that challenges our thoughts regarding how normal and fanned out things are in the universe. It's conceivable that these flying universes are more normal than stars, which raises fascinating inquiries concerning the chance of life in these brutal spots. Might life at any point exist under a thick of ice that is warmed by geothermal intensity on a planet that is traveling through the virus space? The conceivable outcomes make us consider some fresh possibilities and push us to track down better ways of distinguishing things as we keep on investigating space. Concentrating on maverick planets not just assists us with finding out about how planets structure and how they stay alive, yet it likewise opens up additional choices for our quest for life past Earth. Presently, we should direct our concentration toward an intriguing area of enormous review that gazes straight into how life started. Complex natural synthetics have been found in the protoplanetary circles around youthful stars by new examinations. These particles, which are now and again called the structure blocks of life, are comprised of various carbon-based substances that are important for life on Earth as far as we might be concerned to start. Protoplanetary circles are thick areas of gas and residue that structure around recently framed stars. They are where planetary frameworks start. Complex natural atoms have been found in these settings that are continuously evolving. Subatomic structure blocks like amino acids and straightforward sugars are made through compound responses accelerated by the youthful star's energy and various exercises in the circle. These atoms being found in protoplanetary plates is significant on the grounds that it implies that the structure blocks for life might be fanned out across the universe inside the circles that at long last met up to shape new planets. This implies that necessary conditions for life to begin happen from the get-go when stars and planets are being framed. You can imagine a protoplanetary plate as a tremendous kitchen in space where various materials are combined as one to make a recipe. The circle blends gas, residue, and natural particles under the effect of heavenly energy, like how a dough puncher blends flour, sugar, and eggs to make a cake. This could prompt the development of planets that can uphold life. This enormous recipe sets the stage sometime before planets even completely structure. This intends that in the event that life begins to frame on a planet, its fundamental structure blocks were likely gotten rolling from the get-go in the existence of its star. This finding not just assists us with looking into where life could begin, yet it likewise opens up the conceivable tenable zones to incorporate a more extensive scope of planetary settings. We never again need to search for planets with life on them. Presently, we can ponder how life could start in the space between the stars. The investigation of complicated natural synthetic compounds in protoplanetary plates prompts better approaches for searching for life past Earth and brings up fascinating issues about whether the structure blocks of life are the equivalent all over the place. We gain some useful knowledge about the circumstances that could permit life to begin wherever in the universe as we keep on concentrating on these vast homes. As we proceed with our investigate the peculiar, we should investigate the unusual things about Kepler 78b, a planet that apparently shouldn't exist in view of ordinary thoughts regarding how planets structure. This extrasolar planet questions our logical thoughts. However, it additionally catches our minds with highlights that are like Earth. In 8.5 hours, Kepler 78b makes a round trip around its star, which is a lot nearer than Mercury is to our Sun.